Our lesson today is to be able to use properties of operations to write equivalent expressions. Right? We have two Common Core standards that we're addressing, 6EEA3 and 6EEA4 today. I'm going to start by looking at a couple of examples to see just how these properties work. Alright, so let's start with the first one, the commutative properties. Which of the following are true? Is 3 plus 5 the same as 5 plus 3? Right, 3 plus 5 is 8, 5 plus 3 is 8. So the answer to that would be yes. Right, that's a true statement. 3 plus 5 is the same as 5 plus 3. Let's see if it works for multiplication. 9 times 3, that's 27. 3 times 9 is 27. So this is also a true statement, right? The answer to that is yes. Let's see if it works for subtraction. 3 minus 5. Well, that's a negative number. If you take 5 away from 3, you actually get a negative number, which would be negative 2. 5 minus 3 is positive 2. Negative 2 does not equal positive 2, so the answer to that is no. 9 divided by 3, is that the same as 3 divided by 9? Right? The answer to that would be no, because 9 divided by 3 is 3. 3 divided by 9 is actually 1/3. So the answer there would be no. Alright, so what does this illustrate? It says that the true equations show the commutative properties of addition and multiplication. Why do you think they're called the commutative properties? Well, they're called the commutative properties because notice that the numbers actually move. The order changes with the commutative property. 3 was first, and then 5 was second, and then 5 was the first number, and 3 was the second number. The order of the add-ins changed, and when the order of the add-ins change and you get a true statement, that's an example of the commutative property. 9 times 3, 3 times 9. Notice the order of the factors change. Right? The order of the factors change, and if the order of the factors change, that's an example of the commutative property as well. The order has to change in order to use the commutative property. If we look at our next example, the associative properties, right? Let's see which are true and which are not true. We'd have to do the parentheses first. 3 plus 1 is 4, 8 plus 4 is 12. Right, so I get 12 over here. 8 plus 3 is 11. 11 plus 1 is 12. So this would be a yes. 8 plus parentheses 3 plus 1 is the same as 8 plus 3 in parentheses plus 1. See if the associative property works for multiplication. 6 times 2 is 12. We'd have to do the parentheses first. 12 times 12 is 144. 6 times 12 is 72. 72 times 2 is 144. 144 is the same as 144, so the answer to that equation would be yes. Right? That's a true statement. Notice that the grouping changed in each example. In the first example, 3 and 1 were grouped together. In the second example, the 3 and the 1 were no longer grouped together. The 8 and the 3 were grouped together. We can change the grouping, but the equation still remains true when with addition. The same can be said for multiplication. Notice that in the first, on the left side of the equation here, the 6 and the 2 are grouped together. On the right side of the equation, the 6 and the 2 are no longer grouped together. We have the 12 and the 6 grouped together, but the equation remains true. Let's see if the same can be said for subtraction. 3 minus 1 is 2, so this would be 8 minus 2. 8 minus 2 would be 6. 8 minus 3 is 5. 5 minus 1 is 4. Does 6 equal 4? The answer to that is no. Right? The associative property does not work with subtraction. Let's see if it works with division. Notice that 12, 6, 2, 12, 6, 2, right? So same digits. 6 divided by 2 is 3. 12 divided by 3, well, that's going to give us what? 4. Right, so that's 4 over here. 12 divided by 6 is 2. 2 divided by 2, that gives us 1 over here. Is 4 the same as 1? The answer to that is no. So the associative property does not work with division either. The associative property works with addition, and the associative property works with multiplication. The true equations show the associative property of addition and multiplication. Why do you think they're called the associative property? Well, because the associations change, right? Who are you grouped with? Here the 3 and the 1 is grouped together. Here the 8 and 3 is grouped together. When the grouping changes, but notice the order stays the same. 8, 3, 1. 8, 3, 1. Right? The order stays the same. 12, 6, 2. 12, 6, 2. The order stays the same, but the grouping changes, and that's how the associative property works. All right? Some key ideas. Expressions with the same value, 12 plus 7 and 7 plus 12, they're called equivalent expressions. You can use the commutative and associative properties to write equivalent expressions, right? And that's what we see here in our key ideas, all right? And we just kind of went through those examples when on the previous page. In words, the commutative property says changing the order of the addends or factors does not change the sum or product. 5 plus 8 is the same as 8 plus 5, right? The commutative property works with addition. 5 times 8 is the same as 8 times 5. Commutative property works with multiplication. If we're using variables, right, that's what the expressions or the commutative property would look like. With our associative property, changing the grouping of the addends or factors does not change the sum or product, right? 7 plus 4 is grouped together. Plus 2, that's the same as 7 plus 4 plus 2. And it works for multiplication as well. All right. Well, let's see how we apply this. When we apply this, when we want to simplify expressions. If I look here at this first expression, I have 7 plus 12 plus x in parentheses. Well, I can't add 12 and x, right? Can't do that. I can't add 12 and x, so I must use my associative property here. So instead of the 12 and the x being grouped together, I'm going to group together the 7 plus 12, right? They're going to be grouped together in a parentheses because 7 and 12 I can't add together. Notice I didn't change the order of the addends. 7, 12x, 7, 12x. Did not change the order, I just changed what was grouped together. And then I simplify. 7 and 12 is 19. 19 plus x would be my simplified expression. Understand that this is an equivalent expression to this first expression, right? They have the same value, which means if I replaced x with any number, I would get the same value for each of these expressions. Let's take a look at example B. I have 6.1 plus x grouped together plus 8.4. I can't add terms that are not like terms, right? But if I group these two together, right, I wouldn't be able to add the x and the 8.4, right? I can't just change the grouping without changing the order. So I have to use my commutative property and change the order. So I'm going to write 6.1 plus 8.4, right? We're going to group them together, and then we're going to add x, right? But I changed the order of the addends, and because I changed the order, that's an example of the commutative property. Right. Now, I'm using the associative property, right, because I'm now grouping these two together. So when we add 6.1 and 8.4, that's going to be what? 14.5 plus x, and that's my new simplified expression. If I want to simplify this expression, I can use the associative property here because I could just change the grouping. Instead of 11 and y being grouped together, I'm going to group together the 5 and the 11. Right? They're going to be grouped together. And then I'm multiplying that by y. Notice the order didn't change. 5, 11y, 5, 11y. The order doesn't change, just the grouping change. That's an example of the associative property. Then I can multiply 5 times 11. That's going to be 55y is my simplified expression. Right, if you're going to try some of these on your own, explain each step. Right, if I have a and 9 grouped together in this first example. If I try to group a and 10 together, right, I can't do that either because they're not like terms either. So I have to change the order. So I have to do 10 plus 9 plus a. I have to change the order here. And by changing the order first, and then I regroup, So this is going to be 10 plus 9. Going to add them plus a. That's going to be 19 plus a. And explaining each step, this is going to be the commutative property here, and then I use the associative property. All right. My next example, I have C and 2/3 grouped together. Here I can just change the grouping. So I'm going to write this as C plus 2/3 plus 1/2. Notice the order doesn't change. I simply change what's grouped together. And then I can add the 2/3 and 1/2 together, right? So that's going to be C plus, finding a common denominator, so that's 4, 6 plus 3, 6, right? 1/2 is 3, 6, 2/3 is 4, 6. So that's C plus 7 over 6. That's C plus 1 and 1/6. All right, here, this is going to be the associative property. All right, and then we add, we find common denominators, we add, and I get C plus 1 and 1/6. My last example, I simply have to change what? The 5, just the grouping here, right? So I don't have to change the order. The 5 times the 4, I'm going to group them, and then times the n. So the order doesn't change, just the grouping change. So that's an example of the associative property. 5 times 4 is 20 times n. It's going to be 20n. So this would be an example of the associative property here, right? That's the associative property. All right, let's continue. We also have the addition property of 0. The sum of any number in 0 is that number. 7 plus 0 is 7. You guys did learn that last year. In words, the product, we have the multiplication property of 0 and the multiplication property of 1. The product of any number in 0 is 0. The product of any number in 1 is that number. It's also called the identity property of multiplication. And here are some examples. So let's simplify some expressions using those properties as well. It says to use the associative property of multiplication first. So that means that 9 times 0 is going to be grouped together. Times p. 9 times 0 is going to be 0. 0 times p, right? That's going to be 0. Anything times 0 is 0. The multiplication property of 0. If I simplify the expression using the associative property of multiplication, we have 4.5 times r times 1. I'm going to group my r and 1 together, right? That's the multiplication property of 1, right? 1 times r is going to be r. So we have 4.5 times r, and that's my simplified expression. All right. You and 6 friends play on a basketball team. A sponsor paid $100 for the league fee, plus and X dollars for each person's t-shirt. So we paid $100 for the league fee, plus X dollars for each person's t-shirt. Well, you and 6 friends, that's 7 people that have to have a t-shirt. And then you paid another $68.25 for trophies. $68.25 for trophies. Write an expression for the total amount paid. Well, this is the expression for the total amount paid. But if I want to simplify that expression, I have to change the order of my addings. So that's going to be 100 plus 68.25 plus 7x. I can add 100 plus the 68.25, so that's 168 and 25, plus we have 7x, and there's my expression. That would represent the total cost for the league. All right. Problem 4. If I'm simplifying the expression and explaining each step, first we have the 0 property. So b times 0 is going to be 0. All right. And then 12 times 0 is going to be 0. So that's going to be 0 for the answer. And if I'm explaining each step, that's my 0 property. Right, that's the 0 property. Problem 5, I have 1 times m times 24. I'm going to use my identity property. 1 times m is m, m times 24, I would write as 24m. Right, so here I used my identity property and multiplied 1 times n. Problem 6, we have t plus 15 plus 0. I can't add t and 15 together, but I can add 15 and 0. So t plus 15 plus 0. I'm using my associative property to add the 15 and the 0 first. 15 and 0 is going to be 15. So I'm left with t plus 15 as my expression. And then finally, problem 7 says, if we had to pay $54.75 for trophies, what's the total amount the sponsor paid? Well, that's $100 plus 7x plus $54.75. I have to change the order of my add-ins, so that's the commutative property. So it's 100 plus 54.75 plus 7x. We add the 100 and the 54.75, so that's 154 and 75 plus the 7x, right? And that's my simplified expression. I can't add 7x with the 154.75 because they're not like terms, so that will give, that's the expression that gives me the total cost. All right, so that's the end of the lesson today. Kind of a short one, but hopefully that was helpful.